See, now we are going to see now what wavelength means. You could see, suppose a point that is no on the wave, you could see the waves. Okay, so on the peak of the waves, two waves, suppose a molecule is moving, vibrating from one point to the another point. That red color which is shown there, that is the wave period. So that we call it as wavelength. Okay, and that period, that is the molecule moving from one point to the another point. Okay, in that time, so we call it as the frequency. So in that wavelength you could see the compression and the expansion, that is rarefaction. So we will understand what wavelength is, so what wavelength of that sound as well as its frequency. So the length of that wave, okay, the length of the molecule or the distance the molecule covers while vibrating, so that we call it as wavelength. And that wavelength is denoted by the letter lambda. Okay, that letter is a Greek letter. And how many times this wave comes, okay, how many times this wavelength is, so that is indicated by the frequency. So its frequency is denoted by nu. Okay, now wavelength, how many times the molecule will vibrate, once, then twice, till it comes back to its original place. So that is called as the frequency. So what frequency is, the wavelength you have understood. Again we will still go deep what frequency means. The frequency, it is given by, denoted by the letter nu, nu, that is the pronunciation. But nu here you could see in your textbook 128 page, that nu, that letter looks like the u. So it is also a Greek letter. So the amplitude, which is the maximum value of the pressure or density, is indicated by A. Amplitude means the distance of the vibration, how many times the vibration is, how much strong it is. Okay, the strength, the pressure, that we call it as the amplitude. Okay, so that is given by the letter A. Oscillation time is given by letter T. The value of frequency determines the pitch, high or low, whether the sound is high or whether the sound is low. That we call it as pitch, pitch of the sound. This pitch word comes from the frequency of that wavelength. So let's see what frequency is. Here you could see the amplitude. The molecules vibrate. This can go still deep down. Okay, that zigzag lines could go deep down. That is the amplitude, the vibration of the molecules, the pressure created by that sound, so that the molecules vibrate. Okay, so that is called as the amplitude. And the distance between the two wave, we call it as a wavelength. So frequency, 2 cycle per 1 second, we call it as 2 hertz. 2 cycle means, suppose an oscillation is taken, suppose if you are moving your hand up and down like the wings of the bird. Okay, so once you move towards your right, then towards your left, again come to the original position, that is in middle. So that is once, and again the same action, that comes in 1 second. If you are doing this 2 times in 1 second, we call it as 2 hertz. If it is done in 20 times 1 second, then we call it as 20 hertz. Okay, if it is done 20,000 times in 1 second, then we call it as 20,000 hertz. Okay, so that is called as the frequency, how many times the molecule vibrates in 1 second. See here the high frequency and the low frequency. High frequency wave, you could see the first one, the pressure is created in the atmosphere more, so the frequency is high. You will find the waves are too close to each other. Okay, so that means this frequency is high. Low frequency is very soft sound. Okay, therefore the pressure created on the medium is low, therefore frequency was also low. If we shout, okay, if I am singing, that means the frequency is high. Okay, if I am speaking very low in a low volume, then the frequency will be very low. Okay, so this way high frequency waves you could see and low frequency wave. The same way high frequency, that is high pitch sound. Oh, the female sound is there. Female sound, when female is singing, her sound is said to be the high pitch sound, okay, than the male sound. And here you could see low pitch sound, that means in very soft. Here now high pitch sound, in 1 second how many waves are found, and in low frequency low pitch sound the waves are far away from each other. Okay, so the distance covered by a point on the wave. Okay, suppose there is a point on the wave and this point covers that distance on the wave. So that point, or that we call it as distance, we call it as velocity of the sound. So velocity, usual our formula, it is velocity is equal to distance upon time. So any point on the sound wave covers a distance equal to lambda. Now the wavelength, we call it as lambda in time t. Distance means the wavelength. Okay, that point is traveling from one wave to another wave, one point to another point, there it forms a wave. So that is given in that particular time. So here now the formula of velocity of sound will change and it will become distance upon time. It will become now wavelength upon time. Okay, see this wavelength is now, it is the number of frequency, the number of waves found, number of wavelengths are found, that is the frequency. So the frequency into the lambda. Okay, so frequency multiplied by, that is the nu multiplied by lambda. Okay, so 1 upon lambda is equal to, okay, 1 upon t is equal to mu. Getting that? What do you mean by frequency? The number of time, the number of those molecules into the time. Suppose a bus is traveling to your bus stop. How many times the bus travels? In what time? How many times? So that is frequency is directly proportional to 1 upon t. Okay, you have to write down frequency is directly proportional to 1 upon t. That means if time is less, frequency is more, and if frequency is less, time is taken more. So here also the same thing is applied. Frequency of the wavelength. Okay, if frequency is more, that means time taken is less. That means within short time, many times the wavelength is, waves are formed. So velocity is equal to lambda upon t, or velocity is equal to nu into lambda. So that formula you have to understand. So velocity of the sound is equal to wavelength into frequency. So this wavelength into frequency, what wavelength and what frequency? It differs according to the substance. Why it differs according to the substance? As we have said, velocity of the sound changes into different substance, as in solid, then in gas, and then in water, because of the molecules present in them. We are talking about the vibration of the molecules or vibration of the particles. So if particles are very far from each other in that substance, then the frequency will be, that means the oscillation will be more. Okay, we will find the wavelength, that means the sound frequency will be more. The particle will get more place to vibrate. Okay, so what happens here? The velocity of the sound is different in different substance. So it increases with the increase in the temperature of the medium. Now why it increases when the medium temperature increases? Because when temperature increases of a substance, what happens? The molecules of the substance are sent far away from each other. If molecules are far away from each other, they will get proper place to vibrate. If they vibrate many times in that place, then what will happen? Here the frequency created of the sound will be more. Are you getting? The frequency created in the sound in that medium will be more. The sound frequency will be more. That means our sound is able to vibrate the particles. If particles are tightly packed, then what will happen? The vibration which is been taken, that vibration will be slow. That means only little, the molecules will vibrate little because they are being packed by other molecules. Okay, so there the frequency will be low of that sound. So here you will find in your textbook they have given solid, okay, that is aluminium. What is the speed of sound? Meters per second it is in meter. So 5420 meters in 1 second in solid, that is aluminium, nickel, steel. See, sea water, pure water, ethanol, okay, air. These values you require to remember of air, water. If you get the exam, no, if you get the numericals in the exam, you should know these values. The speed of sound in air, the speed of sound in pure water, the speed of sound in seawater. But the temperature here, this range is at the temperature of 25 degrees Celsius. Now if suppose temperature increases, then whether the speed of sound will increase or decrease, that you have to think. If temperature of these substances increases, then the speed of sound will increase or decrease, that you have to think. So the velocity of sound in gaseous medium. Now what happens here? Whether if the temperature increases, the velocity of sound is directly proportional to the square root of the temperature of the medium. This means if temperature increases 4 times, the velocity becomes double naturally. Now if temperature increases, what will happen? The particles of that medium will get placed to vibrate. So naturally velocity of the sound is going to become double. It will get placed to travel from that medium, isn't it? Sound will get placed, or the particles will get placed to vibrate. Now think if density increases. If you take any dense particle and try to put your sound inside, what will happen? The velocity of sound is inversely proportional to the square root of density. If you increase density 4 times, then naturally velocity is going to decrease. It will become to half of its value. Okay, now if density is increased, what will happen? The particles will not get proper place to vibrate, and the frequency will become low. Molecular weight, the weight of the molecule of that substance, if it is increased 4 times, then what will happen? Naturally the velocity also will be decreased to half. So naturally if the molecules will become weight, will become heavy, then naturally it will get less momentum at beginning. Okay, so here now they have given one example of molecular weight of oxygen is 32, while that of hydrogen is 2. Okay, then whose molecular weight is more? That is of oxygen. So you have to prove under the same physical condition, the velocity sound in hydrogen is 4 times than that of oxygen. Okay, in hydrogen sound is traveling in a great frequency, loudly or smoothly, than in the oxygen, because oxygen molecule weight is more. So for a fixed temperature, the velocity of sound does not depend on the pressure. Okay, so you have to read these and learn the formulas of velocity. We will study the next topic, that is audible, infra and ultrasound. But till here, velocity of sound in the gaseous medium. This was all for gaseous medium. Okay, if temperature of the gases increases, if density, why they have given gaseous medium? Because our atmosphere itself is a gases, and when we are talking with each other, it is naturally going to that column of the air, which is the gaseous medium. Then think, if your temperature increases, that is in the afternoon, in the morning, in the evening, what will be the speed of sound? Whether it will be affected or not affected, that you have to think. Whether it is a foggy night or the foggy day, whether you are there in the water, all these things will affect your